Okay, today we are doing spheres and sections. So, a sphere is basically a circle in 3 dimensions. First of all, let's just remember what the definition of a circle is. You may remember my son had circles that kind of looked like this when he was about 2 years old, and we found out that that's not a circle because the definition said the distance to the edges from the center always has to be the same. And the way my son was drawing them, that wasn't the case. So let's write that really quick. The circle is the set of 2-dimensional points from a center with the same radius. Okay, so if I have a center here, and if I draw a circle around it, any direction that I head out from the center, the measurement right there should be the same. We call that the radius. So the next step is to think about, well, a sphere is a 3-dimensional circle. So we would call this the set of 3-dimensional points from a center with the same radius. Okay, there's probably an easier way to say that, but if I want to draw a sphere, draw a big circle like that, and then draw an axis like that. That's kind of like the equator, and a point in there. So if I was to draw dotted lines from the center out to any point on the circle, or sorry, the sphere, if I go back on the back wall, or if I go straight across all the way to the equator, all of these lengths should be r in every direction. And that is how we define a sphere. Okay, so we are going to then now move on to a program that will show us a sphere in 3-dimensional space. Okay, so it's floating above the table like this. Now, I want to prove a point here. I can create little segments from point A out to the circle, anywhere around the circle here. And no matter where I place that point, that distance right there is always going to be the same inside that circle, inside the sphere. Okay? Now, one of the things that we need to keep in mind here is that we have to think about how we're going to be, if we were to cut this sphere at certain ways, what kind of shape would we get? And so I have created this plane below here that can go right through my sphere. It can travel right through it like this. Okay, so if I'm just anywhere along the circle here, I'm tracing a shape. You might be able to see that where these intersect, it's going to be a circle. Now, if I was to adjust my plane so that the plane is going right through that center point A, oh, it's almost there. Okay, I think that's it. The plane is going right through that center point in that sphere. And if that's true, the outline of this sphere right here is called the great circle. Another way to say this is that when the plane cuts right through the center of a sphere, the circle, or the equator that's kind of made right there, that's the great circle. Now what happens if I'm not exactly halfway in the sphere? What if I go up above and I cut at a place not right in the center? Well, you can see here that I still get a circle. It's just going to be a smaller circle than the great circle. The great circle is called the great circle because it is the largest circle you could get by cutting at different angles on my sphere. Okay? And then the last thing you could get, you might raise the plane just so that it just nicks the top of your circle. Now, it's not showing it here, but there is a spot, a single point right at the top of that sphere where it's touching the plane. And so this plane, it's called tangent. When something just touches but doesn't actually go through, that's called tangent. And so there are 3 things that you can get by cutting spheres at different angles. We're going to write those down in our notes. Okay, So we call these sections because sect means to cut or slice or to part. So we talked about bisect. It literally means to split into two parts. Okay, so sections, we might have three things that could happen. Here's one sphere, and if we have a plane that just barely rests on the top of my sphere, it might intersect at a single point. And remember that this is called a tangent plane. Okay, tangent means it just barely touches, but it doesn't actually go through more than once. The other thing that could happen, you'll have a sphere here. And then if the plane is passing just above, it will be cutting another circle right there. So it's above the point in the center of the sphere. It's going to cut this circle right here. And so you have a smaller circle, just a plain circle. Now, if you take a sphere and you cut it so that it's cut exactly in half, that part right there, that circle is called a great circle. So one question you might see, they might give you the radius of from the center out, and they would ask you, what is the great circle area in the sphere? And you see the circle right here through the center is going to be your great circle. So you just have to do pi r squared with the radius. Okay, now we have to talk about surface area. Surface area, it's kind of hard to explain where this proof comes from. So I'm going to give it to you and then just note something really weird about it. The surface area of a sphere is pi r squared, but a 4 in front there. So if you have a sphere, and let's just do an example here. Let's say we have a radius of 7 centimeters. And so we have a ball that's about 7 centimeters, and the sphere would be about this wide in diameter. We want to know how much of the surface there is. We're not talking about anything inside of the sphere. So if you were to draw a picture of it, from here out is 7 centimeters. The surface area is 4 pi r squared. So this would be 4 times pi times, and 7 squared would be 49. All right, so now we have to do 49 times 4 times pi. So let me get my calculator out here. 4 times 49 times 3.14159. Now I'm going to round this up because there's a 5 right after the first digit. It will be 615.8. And now this is surface area, so this would be centimeters squared. Okay, so the interesting thing to me is, back in the formula, this pi r squared is just the formula for a circle. And this right here is actually just the area of the circle you would get if you used a radius of 7. So the really interesting and amazing thing to me is that the area of a sphere is just 4 times what it would be right in the center of that great circle. What would the area of the great circle be? Whatever you find there, then you just times it by 4. It'd be the surface area, which I think is kind of cool. Now we're going to do one more thing here. I have to look something up. And I forgot to do this beforehand, so we're just going to use Google here. What is the radius of the Earth? Okay, so 3,000, and we'll go with 960 miles. So this is example 2. Example 2, the radius of the Earth is 3,000, and I want to make sure I get this right, 3,960, about. I'm just rounding a little bit. 3,000, and this is miles. Now you may know this about the Earth. The Earth isn't perfectly spherical, but it's close enough so that we can get a pretty good estimate. We want to know, what is the surface area? Okay, so you do SA equals 4 pi r squared. And then in this case, the radius is just 3,960, but we're going to have to square that, so we're going to get a really big number. Just one thing, be careful because sometimes they give you the diameter. If they give you the diameter, make sure you're cutting that in half before you put it in for the radius. Okay, let's clear this out. We do 4 times 3,960, and to square that, I'm just going to do times 3,960 again, then times 3.14159. All right, I have to write this down. 1836 24678. And then if we round to the tenths like we have been, it's about 0.9. Okay, so that means if I put in my commas, the world is 184 million square miles. So I'll write miles squared here. Okay, that is a huge number. So just to compare it, let's look up the surface area or the number of miles squared in Minnesota. Okay, Minnesota is 86, almost 87,000 miles squared. So let's quick write this down just to make a comparison. Minnesota is 87,000. Okay, so the question you might ask is, how many Minnesotas would fit all around the world if we were to cover the world with Minnesotas? So what that means, or how I would figure that out, is I would take the number of miles squared in the world and divide it by the number of Minnesotas. The surface area in one Minnesota will give us one Minnesota. So let's take this and divide by 87,123. And this is just to get an idea. You could fit over 2,000 Minnesotas all around the world. So think about the size of Minnesota, and that is a big world. So we are 1/2000th of the world. That's our area there. All right. So just remember, please, a few things. Make sure that you are including that 4 in front of pi r squared. Remember that pi r squared is the circle of the equator of the sphere. If you were to cut that in half and just look at the area of the circle, and the surface area is 4 times that amount there.